Aren't you loving this trip to New Zealand? I love the Southern Hemisphere.
Night hikes are the best.
Whoa! What's that? In the rotting leaf litter on the temperate tropical forest floor!
Is it a spider? What's that other thing?
Oh, did you see that white sticky substance being shot at the spider? It's coming through those two specialized slime papillae near its mouth.
Oh, and now it's injecting digestive saliva into it using its fangs.
Weird. It must be carnivorous.
You know what? I think it's an Onychophora.
Ooh! A velvet worm. Did you know Onychophora means claw bearer in Greek?
You guys, I want it as a pet. Can we go to the pet store tomorrow?
Sure.
Down.
Wow, what an amazing pet store.
Hey, what can I do for you guys?
We're looking for an Onychophora, the phylum that has over 200 species.
Oh, one of my favorite relatives of the arthropods, and a pseudocoelomate as well. However, we don't sell those. No way can you find the two extant families of the Peripodopsidae and the Peripatidae at this store.
Oh no. But we would love to get more information if you have more.
Well, you know what? That in order to breathe, these protostomes use trachea attached to spiracles. They also have open circulation, a hydrostatic skeleton, and 3 tissue layers.
That is unreal. But wait, are they always going to look like slugs with legs?
Well, young are fully developed when born, and apart from lacking complete pigmentation, they look like miniature adults. Hey, want to know a cool trick? If you pour a little bit of water on these guys, the water will drip right off.
Wow, its skin must be hydrophobic, giving way to its velvety appearance.
How do they reproduce? Velvet worms undergo sexual reproduction in a pretty cool way. Females can be dermally or vaginally inseminated by males, and once fertilized, they can either lay eggs, carry eggs, or have live births depending upon the species of worm.
That's such a crazy and fun fact about the Onychophora. Let's go catch us some Onychophorans.
Count me in.
In the data matrix tree, the Onychophora's closest relative is that of arthropods, while in the 16S RNA tree, the closest relative is mollusca. This difference can stem from the fact that the data matrix covers specific characteristics, while the 16S tree covers only DNA. As we were creating this data matrix based upon specific characteristics, one such as having an open circulatory system, Onychophora and Arthropoda were thus grouped together as sister taxon. Based upon fossil record, this phylum started as aquatic inhabitants 250 million years ago and then evolutionarily made their way towards terrestrial life, with little change in characteristic except that of the introduction of modified legs. We can thus hypothesize that what we see today with the Onychophora is very similar to their ancient form. By following the tree put out by Casey Dunn in Nature Journal, we were able to see that the Onychophora stemmed from Pan-Arthropoda, with the next common ancestor being Protostomia. Our tree was generated in lab, and the published tree contained very similar characteristics, and that both display Arthropoda and Onychophora as sister groups. The published tree was established through express sequence tags, which give way to the ability to sample diverse genes from a large number of taxa. As trees are only developed through specific criteria, Dunn's tree could have analyzed DNA that links Onychophora closer to Arthropoda than that of mollusca. However, there can be inaccuracies in phylogenies due to the characters that develop convergently, such as eyes or wings. Many species can have these characters, but that does not mean that they are related. Additionally, trees can prove to be subjective, as the creator picks the criteria to be used.
Hey, by the way, I noticed your hat. Did you go to LMU?
You know what? I did go to LMU.
So how'd you get into this job?
You know what? I took Bio 111, section 14 in fact, and it really changed my life. My TA, Caroline, greatest out there. My professor, Dr. Dowd, oh my goodness, Dowd is down with it. And you know what? Our lab assistant, Tatiana, was always there for us. And you know what? I just credit my whole entire career, everything to this class.
They must be wonderful people.
Wonderful people.
It's great for you to acknowledge their efforts.
I always want to acknowledge